Hello, it is January 2024. This is part 3 of the Cromemco test system rebuild. Just switched on the machine and let's get the old go running. Escape to break out of that. By the way, what you're looking at there, those upward carrots, it's doing a memory test. So it's testing 0 to F, so that's 16 4K segments for a total of 64K. Now this system can address much more memory than that because it's got a 68,000 processor. However, this is the compatibility mode of RDOS, the resident disk operating system, which is sitting on the 64 FDC floppy disk controller. And I realised in previous videos I keep referring to disk controller because in the old days a disk controller was always a floppy disk controller. And you'd always say something like a hard disk controller, but I must do better, and so I'm going to try and say floppy disk controller when I mean floppy disk controller, and hard disk controller when I mean hard disk controller. So, right, at the end of part 2, I had almost a working system. I had, in this machine, I've got 3 physical drives. One has just fallen over. I'm stuck with tape at the moment. We've got 3 physical drives. We've got one which is a HXC, which can emulate 2 virtual drives with a SD card, not a micro, a full-size SD card. We've got the 360K 5¼ inch floppy, which is the floppy that came with the Cromemco system. I'll just switch the lights on. Very professional, this video. Alexa, turn on face. Better. Okay, and the third drive is the 3½ inch drive, which is emulating the 8-inch floppy. So I'm going to put in the 3½ inch diskette. You hear that? And I'm going to close the drawer on the 5¼ inch diskette drive, closed. And the HXC remembers the 2 drives that previously were selected. So, drive A and C are the HXC. So we should be able to, on the latest release of RDOS, which was 3.12, which is this release, on the 64 FDC diskette controller, there's a function called TZ for test the system. So first of all, I'm going to do a TZ on which test the memory. Then it's going to say, do I want to test the floppy or the hard? And test the floppy. I'm going to test drive A. Now drive A is simulating an 8-inch drive. So it's a large drive, large meaning 8-inch floppy. Speed, fast or slow. So in the olden days, when Cromemco first brought their systems out, they had voice coil drives, a pair of per side voice coil drives, and they were very fast seeking drives. So in the industry, when floppy disks first came out, they used something called a humble stepper motor, and that would just step. It stepped in a certain amount of millimeters per track, and each track would step in a certain number of milliseconds. For example, 5 milliseconds, 10 milliseconds, 15 milliseconds. Well, there was an alternate system that came out by a company called Persei, and they had this thing called a voice coil actuator. It was a linear voice coil, and that could go from start to finish, and it could actually accelerate and decelerate, so it was much, much faster. So Cromemco were the kind of expensive end of the industry. So they had these drives. So this is a long-winded explanation to say that if I press F, it won't work because it'll try and drive a per side interface. So we need S for slow. That is all working. You can see it does a seek test, it's done a read test, and I can hit enter to do the right test. I'm so confident. Yeah. So we've got A:::, which is saying that it's a large drive. 3 colons will be a small drive. 2 colons means a large slow drive. and a single column will be a large fast drive. So that is correct. So we've got A drive and C drive. Now I happen to know that the C drive is containing the full operating system. So we're going to say B for B for boot, and C for the drive. So we're going to boot, said confidently. You see the word standby, it means it's red, the first boot sector. So as soon as you see standby, you should be pretty confident things are going to work. Hooray, we're booted. So I'll do a dir command. Oh, I forgot to mention, so the purpose of this video is to check that all 4 drives work. At the end of the last video, we had 3 out of 4. So we're going to do the first 2, which shouldn't be, it's the first two physicals, which is 3 actual, 2 virtual plus 1 physical. We're going to finish with the last drive, which I now believe is fixed. And we're going to see what the difference is. So here's the dir of the C drive, which has booted. Oh, and I should mention that in these olden days, when you booted the system, you had to generate the operating system for the diskette drives that you had in your specific system. Now, for CP/M, things were not very as advanced as with CDOS. I'll just get the microphone clearer. Hopefully that's going to make it a better sound. In the early days, Cromemco was far ahead of digital research as CP/M, and it had a much more user-friendly way of generating the system. It had a program called CDOS Gen. I'll just start that now to show you that I have actually got dir cd star.star. Of course, it's 8.3 naming conventions, so CDOS Gen is a 34K program. I'll just load the program and show you. I won't complete the program, I will just start the program. CDOS Gen. There's an older version here. That's a generation program for an older version of CDOS, which I've named for the earlier releases of CDOS. So I'm just going to try and show you that it's asking for, obviously I very, very stupidly got the window here. Can I move that to the top? Oh, I can. Right. Okay, so now we can see that it's asking you to, this is to generate the cdos.com program. So CDOS Gen will generate a cdos.com program. I'm not going to let it finish, but I want to show you what the questions are so you can see what I mean. So that's the memory size, and now it asks you for the 4 drives. So the drive A is a large drive. It's a virtual drive, but it's a large virtual drive. The seek speed is not voice call per se, it is the fastest. It's a virtual drive, so it's not 1 millisecond, it's way below that, but the fastest we can achieve is 1 millisecond. Is it a single or dual drive? Well, it's a single drive. A dual drive means you've got one actuator attached to 2 heads, which is what PerSci had. So it was a pair of drives with 1 voice call. So it's a single drive. And is it double-sided or single-sided? It's double-sided. And is it single or dual density? It's dual density. So you basically go through this A, B, C, and D. I'll just do the second one. So like the B drive is it's a large drive. It's again, it's 3 millisecond. It's a single drive. It's dual-sided and dual density. And the third drive, etc., etc. So you can build up these. In our case, we've got 3 large drives, and the last drive here is the D drive, and that's the small one. So you can see when you finish this, it patches a certain point in the operating system to tell the operating system what's a large drive, whether it's a fast drive or a slow drive, etc., etc. Anyway, I've done all of that, and so the CDOS.com that I am running has 3 large drives and 1 small drive, and you can't see that. I don't know of any way that you can, once you've built the CDOS, look and go, oh, that's got that configuration. Anyway, so we booted to drive C, we've tested drive C, it looks like it works fine. The other virtual drive is drive A, so I'm going to dir of drive A. to the virtual drive. That is working. Look, there are all the programs I'd previously copied from the C drive to the A drive. Now we're going to do the drive here, which is the 5¼ inch drive, and I'm just trying to remember, that's the D drive. So let's have a look at the D drive, DRIR, the D drive. That's working, it's got 2 files on it, but what is the actual stat of the D drive? And that will show us what diskettes in the drive and what the drive is as well. Okay, so this is telling us that we've got CDOS stat program 2.19. We've got a drive which is double-sided dual density, and the diskette is double-sided double density. As you can see, the total disk space is 390K, and that's the space for a 5¼ inch double-sided double density diskette drive. Now, finally, we're going to talk about the last 3½ inch drive, which is physically emulating an 8 inch drive. So at the end of the last video, you saw me trying to electrically modify the 3½ inch drive, and it did not work. So I've had to put that drive in the Silicon Heaven waste pile and convert a new drive from scratch. Nothing I could do would make that other drive work. I busted a pin out and I was trying to recover from that, it didn't work. So I've got a new converted drive, and if I do an init to initialize the diskette, and we select the B drive, that is the physical 3½ inch drive, which is behaving like an 8 inch drive, and it's spinning, as you can see, at 371 RPM. It's a bit out of tolerance, but it's close enough. So that's all I wanted to show you, the fact that it's spinning at the right RPM, pretty much. And if it's already formatted, I've already checked it out, you see, and if I do a DIR of the B drive, you will see, you can't see the light's gone on, the disk load light's gone on, and I didn't want to see that. That was not good. What is happening there? That's just not what I wanted to see. Hang on. Okay, so here's the diskette. Maybe I did not check that. So what we're going to do now is we're going to go from first principles. We're going to do I'm pressing Control C. Now, in the olden days, this is not really an interrupter of an operating system. Control C would eventually write all disk buffers and make the assumption that diskette drives had changed, and it would get through. So I'm going to type the init program again. Demos never work, do they? We're going to get it working. Init. We initialize drive B. We want it to be a CDOS disk. We want it to be double-sided. We want it to be double density. We want to start at 0, and we're going to finishing at 4C hex, which should be 76. A, B, C. Anyway, 64, 64, 74. All surfaces. So now we've got to wait. I'm not going to speed the video up. You're going to watch the whole video. That's it. Now, before we had the DUF drive, it was doing this as well, because it sends an init command. Well, the init program talks to the floppy disk controller, which has got a Western Digital 179X floppy disk chip, and there's a command that's sent to that chip, which tells it to format the track with a number of sectors, but it doesn't. it could, but it doesn't. It doesn't read it back. So it didn't know before. It was doing all of this before, and it was finishing fine. But actually, the speed was wrong. So there is a version on the Cromemco initialization program. So CDOS was the original program that Cromemco came up with, which was basically a superset of CPM. And then they came up with their own Unix-like operating system called Cromemco, which was much more sophisticated. And is still a technological marvel based on, given that it was running effectively a Unix-like operating system on a Z80 processor, Zilog Z80 processor. But some of the later versions of the initialization program under Cromemco would have a look at this value and go, that value is out of tolerance, I will refuse to format or go any further. But under CDOS, no such check was made. So anyway, hopefully, if I do a DIR of the B drive, it should be fine. That's good. Now, let's see if we can write the operating system from the C drive, which is the boot drive, onto the B drive, which is this drive. So we say write system from onto the B drive from the C drive. So this reads from the C drive. There's a big long story to tell about diskette formats as well, which is that Cromemco had this compatibility thing whereby when they first came into business they used single density diskette controllers, and then double density controllers came into fashion. So they thought something really clever. They thought, well, what we'll do when we've got a double density disk controller, which you're looking at now, is we'll continue to write the first track on the first side of the diskette in single density. So typically 128 bytes long, not 512 bytes. And they did this, and they wrote a label on that first track of the first side, or the zeroth side, zero sector if you like. And that contained a 8-digit ASCII label saying if it's a small or a large diskette, and whether it's single or double-sided or single or double density, and in fact single or double tracking. Well, that was never implemented. And this actually caused chaos in today's world when you're looking at vintage systems, because no vintage system has mixed density on a diskette drive, like Cromemco does. So Cromemco has, for diskette formats, there's the special diskette format which is called uniform, but excluding that last format, which is not really used very much, Cromemco has each diskette, the first sector of the first side on the first track is written single density. And like I say, this is very, very difficult to copy, because most diskette copy programs assume that the entire drive is the same. All tracks have got the same number of sectors and same density. But Cromemco does not. So that's caused massive problems for Cromemco users who want to use mixed, who want to use virtual floppy drives. Anyway, that's worked. It's a long waffle while that was working. So if I DIR of the B drive, you'll still see it's blank. And why is it blank? It's because the area where the operating system, the bootloader for the operating system, is hidden. If I do a stat of the B drive, you will see. Come on, baby. So you see the total disk space is 1216K, which is a huge amount. This space used by directory is 8K. We've given it 256 directory entries. In other words, you can store 256 files on this file system. and it's a double-sided dual density drive and a double-sided double density diskette, which is what you expect. So let's just do a bit more of a test. So we do a dir of bstar.com. What we got? Oh, not too much. So we do xfer for transfer onto the B drive from the C drive, banything.com. And I'm often amused when people are talking about transfer speeds of 2,000 megabytes per second or 1,000 megabytes per second. And this is transferring at kilobytes per second. So a kilobyte being 1,000th of a megabyte. So if you're transferring 1,000 megabytes per second, you're 1,000 times 1,000. So you're 1,000,000 times faster than this is transferring. Probably more than 1K, let's call it 10K. So you're actually transferring at 1,000,000 divided by 10, which is 100,000 times faster than this transfer. I mean, it's difficult to think about the speed difference between this system, which is dated 1980, let's say, and a system today in 2024. So we've come on, let's say, 40 years. But we've increased the disk transfer speed by a factor of 100,000. To me, that's bonkers. Right, that's transferred, no errors, and xfer does checks. So if I do a dir of the B drive, yeah, everything is working. So now we have got 4 working disk drives on the system connected to the floppy disk controller. The next thing is to actually look at these packages that have been delivered by Mr. Amazon. And we are going to use these packages to mount these loose diskette drives into a more presentable fashion. So that's the end of, where are we, part 3? Part 3. That's into part 3. 4 working floppy drives. Good night.